You have probably never spent an entire night outside without protection. No walls, no windows, no fan, no mosquito net, just your skin, the darkness, and the constant sound of tiny wings circling your face. Within minutes, your arms begin to itch. Your ankles burn. Every time you close your eyes, another bite jolts you awake. By sunrise, you are covered in swollen red welts. For most people today, mosquitoes are an inconvenience. But for nearly 300,000 years of Homo sapiens history, they were something far more dangerous. Long before cities existed, before medicine, before insect repellent, humans slept in forests, wetlands, and river valleys where mosquitoes were among the most successful predators on Earth. Not because they could kill you directly, but because they carried diseases that could. Today, mosquitoes cause more than 700,000 human deaths every year, according to the World Health Organization. Malaria alone has shaped human evolution for thousands of years. Yet mosquitoes themselves are far older than our species. Fossils show they have existed for at least 100 million years, long before the first humans ever appeared. That means every ancient human who walked through an African savanna inherited a problem that evolution had already perfected. So, why did mosquitoes wipe us out? And if our ancestors had no sprays, no coils, and no screen shelters, how did they survive? The answer begins with fire, but not the way most people imagine. In 2012, archaeologists studying Wonderwork Cave in South Africa uncovered some of the oldest convincing evidence for controlled fire use, dating back nearly 1 million years. Tiny fragments of burned bone and ash were found deep inside the cave, far beyond where natural wildfire could have reached. The discovery suggested that early humans were deliberately maintaining fires long before our own species evolved. For decades, researchers assumed those fires existed mainly for warmth or cooking. Then another possibility became impossible to ignore. Smoke changes the behavior of insects. Modern field studies repeatedly show that even small cooking fires dramatically reduce mosquito activity. In parts of East Africa today, pastoral communities still rely on slow-burning fires at night because the smoke interferes with mosquitoes' ability to locate human breath and body odor. Mosquitoes do not simply see you. They find you by detecting the carbon dioxide you exhale from more than 30 meters away. They also sense body heat and chemical compounds released through your skin. Smoke disrupts all three. It scatters carbon dioxide. It masks human scent. It creates tiny airborne particles that confuse the insect's navigation. Without understanding chemistry, ancient humans may have discovered one of the oldest forms of insect control simply by sitting around a fire. But smoke came with its own danger. Inside caves, thick smoke irritates the lungs and eyes. Long-term exposure increases respiratory disease. Sleeping too close to a fire also increases the risk of burns or accidental suffocation. So every night became a balance. Too little smoke and mosquitoes found you. Too much smoke and breathing became difficult. Archaeological hearths reveal that prehistoric people often positioned fires near cave entrances or open-air shelters where air currents carried smoke across sleeping areas instead of trapping it indoors. It was an elegant solution. Not perfect, but effective enough to keep people alive. Yet smoke alone could never solve the entire problem. Mosquitoes breed wherever still water exists, and ancient humans needed water every single day. Some of the richest hunting grounds also happened to be the worst places for biting insects. Riverbanks, floodplains, marshes, these landscapes offered fish, edible plants, fresh drinking water, and large game animals. They also produced millions of mosquitoes after seasonal rains. So every decision became a trade-off. Stay near the water, and food became easier to find. Move away from it, and insect pressure dropped, but survival became harder in other ways. The archaeological record suggests that prehistoric camps were rarely placed randomly. Groups repeatedly chose slightly elevated ground, rocky outcrops, or breezy ridges overlooking water instead of camping directly beside it. A difference of only a few hundred meters could dramatically reduce mosquito populations because many species struggle to fly against steady wind. Even today, entomologists observe that mosquito activity falls sharply in consistently breezy environments. Ancient humans may never have understood the biology, but after thousands of generations, they understood the pattern. Some places simply felt safer after sunset. Except there was another problem. Not every environment had wind. Not every shelter had smoke. And eventually, humans walked into landscapes where mosquitoes carried something far deadlier than an itchy bite. Around 10,000 years ago, something invisible began shaping the future of humanity. It did not roar like a lion. It did not stalk like a leopard. It arrived through the bite of an insect weighing less than 3 milligrams. That insect carried a parasite called Plasmodium. Today, it causes malaria, but genetic evidence suggests the battle between humans and malaria stretches back tens of thousands of years, deep into the prehistoric past, especially across sub-Saharan Africa. In 1954, British geneticist Anthony Allison made a remarkable discovery. He found that people carrying a single copy of the sickle cell gene were far less likely to die from severe malaria. The mutation could be harmful in 2 copies, causing sickle cell disease, but in 1 copy it acted as a powerful defense against one of humanity's deadliest infections. It was one of the clearest examples of natural selection ever documented. A tiny genetic change had spread because mosquitoes kept killing everyone else. Your DNA still carries traces of that ancient war, and the sickle cell mutation is not alone. Scientists have identified other inherited traits, such as certain forms of thalassemia and G6PD deficiency, that became more common in regions where malaria was widespread. These mutations did not appear because they were perfect. They appeared because, in a world filled with mosquito-borne disease, they offered even a slight advantage. Evolution was making impossible choices. Survive the parasite today. Accept new health risks tomorrow. But here's where it gets stranger. Not every defense came from genetics. Many came from behavior. Anthropologists studying modern hunter-gatherer societies have noticed something surprisingly consistent. Groups rarely remain in the same campsite for long. Among the Hadza, camps shift regularly as food, water, and seasonal conditions change. Similar patterns have been documented among the San people of the Kalahari. The reasons are complex. Food becomes scarce. Firewood runs out. Animals migrate. But frequent movement has another hidden benefit. Mosquitoes thrive in predictable environments. A camp occupied for weeks creates food scraps, footprints, standing water in depressions, and constant human scent. A camp abandoned after a few days leaves little behind. Without intending to, prehistoric humans may have reduced insect pressure simply by living as mobile hunter-gatherers. Movement became a form of protection. Then there was timing. Mosquitoes are not equally active throughout the day. Many of the species that spread malaria hunt most aggressively between dusk and dawn. That created a daily rhythm. As the sun disappeared, fires were prepared. Sleeping places were organized. Children gathered close to adults. The group settled before the insects reached peak activity. This pattern appears repeatedly in ethnographic observations of traditional hunter-gatherer communities living without electricity. Night was never random. It was carefully managed, but even the best camp could not stop every bite. Children were especially vulnerable. Their smaller bodies lost blood more quickly. Their immune systems had less experience fighting parasites. For ancient parents, protecting children was not simply about keeping them warm. It meant choosing where they slept, how close they stayed to the fire, and how the group arranged itself through the night. Archaeologists cannot see these sleeping positions directly, but they can see something else. Care. At Shenadar Cave, Neanderthal skeletons dating back roughly 50,000 years show individuals who survived severe injuries for years. One man had lost part of his arm, suffered major damage to one eye, and lived long after multiple fractures had healed. He could not have survived alone. Someone brought him food. Someone protected him. Someone kept him alive. That same cooperation almost certainly extended to sickness. When mosquito-borne disease spread through a group, survival depended on more than individual strength. It depended on everyone else. Food had to be shared. Children had to be carried. Fires had to stay burning. The group itself became the treatment. There were no medicines, no hospitals, no understanding of parasites, only cooperation. Except even cooperation had limits, because eventually ancient humans left Africa and entered environments where mosquitoes were no longer the greatest danger. They had escaped one enemy, only to meet entirely new ones. Around 70,000 years ago, small groups of Homo sapiens began leaving Africa. Over thousands of years, they crossed the Arabian Peninsula, spread into Asia, reached Europe, and eventually entered Australia and the Americas. Every migration changed something. The climate changed, the animals changed, and so did the insects. In colder regions, mosquito populations became smaller and their breeding seasons much shorter. Long winters froze standing water. High mountain passes and windswept plains offered fewer places for mosquitoes to thrive. But these landscapes introduced entirely different threats. Hypothermia, starvation, blizzards. The danger never disappeared. It simply changed shape. This constant trade-off appears throughout human prehistory. Choosing a campsite was never about finding the safest place. It was about finding the least dangerous one. A riverside offered fresh water but attracted insects. A cave offered shelter but trapped smoke. An open hill reduced mosquito bites but exposed people to wind and cold. Every decision carried a cost, and every generation refined those decisions through experience. Not through written knowledge, through memory. Parents taught children where to collect firewood. Hunters remembered which valleys flooded after heavy rain. Elders recognized which camps became unbearable during mosquito season. That knowledge could not be stored in books. It survived only if people survived long enough to pass it on. Anthropologists sometimes call this cultural inheritance. Information passed from one generation to the next through observation and teaching rather than genetics. It may have been one of humanity's greatest survival tools. A child who learned where insects gathered did not have to discover it through painful experience. They inherited thousands of years of trial and error. Then there was another advantage that most people never think about. Humans became masters of changing their environment. Unlike most animals, we did not simply adapt to nature. We slowly adapted nature to us. Fire cleared vegetation around camps. Branches were arranged into simple windbreaks. Sleeping areas were covered with grasses, hides, or leaves. Some ethnographic studies suggest that certain aromatic plants were placed near sleeping areas because their strong scents discouraged insects, although the effectiveness varied and likely depended on the species. None of these methods eliminated mosquitoes. Together, they reduced the risk just enough. That pattern appears again and again throughout human evolution. Rarely was there one perfect invention. Survival usually came from many small improvements working together. A better campsite, a slightly smokier fire, a stronger social group, a child who learned from an elder instead of making the same mistake. Each change alone seemed insignificant. Combined across thousands of generations, they transformed one of the most vulnerable primates on Earth into the most widespread large mammal on the planet. Today, despite air conditioning, window screens, insect repellents, and modern medicine, mosquitoes still infect hundreds of millions of people every year. According to the World Health Organization, there were an estimated 263 million malaria cases and nearly 600,000 deaths worldwide in 2023. The battle has never truly ended. It has only changed. The next time a mosquito lands on your arm, it is easy to think of it as a minor annoyance. But for almost all of human history, that tiny insect represented something much larger. It influenced where your ancestors slept, how they built their fires, when they moved their camps, which genes survived, and which stories were passed from one generation to the next. Long before cities, hospitals, or science, survival often depended on understanding patterns that no one could see. Not because ancient humans knew what a mosquito carried, but because over countless generations, they learned what happened if they ignored it. That instinct to observe, adapt, and remember may have protected our ancestors long before they ever understood the enemy they were fighting.